like to welcome everyone today to the second in our series of webinars for the Making the Most from Nitrogen project, which is being conducted by Hunter Local Land Services with the support of the University of Melbourne and Queensland University of Technology through the More Profit from Nitrogen program. So today we welcome our guest speakers again. We've got Professor Richard Eckhardt from the University of Melbourne, who is from the Quantifying the Whole Farm Systems Impact of N Best Practice on Dairy Farms More Profit from Nitrogen program project. And also we have Associate Professor David Rawlings from the Increasing Nitrogen Use Efficiency in Dairy Pastures More Profit from Nitrogen program project. So both of these experienced researchers will be both, I guess, taking a different approach today. Richard will be presenting sort of at the higher and modelling level and presenting on some of the outcomes of his research. And then Dave will be drilling right down to the more specific regional aspects from on-ground trials and demonstrating some of the approaches that are now being considered as best practice through his research. And just a reminder that a lot of the work that Dave and Richard will be talking on today is actually part of the new FERT-Smart guidelines that Dairy Australia has compiled from other research, but very specifically from the More Profit from Nitrogen program research effort over the last 4 years. And we give thanks today to both the local land services and the Australian government through the More Profit from Nitrogen program and Dairy Australia. So our first presenter today is Richard. So Rich, I'll ask you to share your screen, turn your video on so we can all see you, and I'll pass it over to you to talk about the higher level and modelling outcomes around nitrogen demand.
All right. Thanks, everyone, for the opportunity to talk again about seasonal demand this time, triggers for changing the rate and timing of nitrogen. Just a reminder of the 4 R's for maximum fertilizer use efficiency: right source, right rate, at the right time, and in the right place. In particular, we're probably covering just the right rate and the right time in this particular presentation. Now, one of the things we started looking at prior to the work that we've currently completed, the recommendation was always for a fairly fixed rate of nitrogen through the year. And we started challenging whether that's actually appropriate, because there are other things that constrain growth rate other than nitrogen. So temperature can constrain growth rate potential, base fertility, species composition, the time of the year. So, and obviously soil moisture is probably one of your big ones. So we looked at a number of sites. So here you've got sites from Tasmania all the way through to New South Wales. And what you're seeing on the graph is the rate of nitrogen fertilizer over 20 years, an average of 20 years, the rate that achieved nearly maximum yield. In other words, you can imagine the diminishing returns curve. When you put on nitrogen, you get to a point where you get about 90% of the maximum yield you're going to get. And then putting on more fertilizer beyond that isn't very effective. It's not very cost effective for you. So if we say, ask our model to tell us what that rate was for different sites, different seasons, you can see, for example, in Tiree in winter, we had a slightly higher rate because you've got annual ryegrass in a subtropical environment with great potential to respond to nitrogen fertilizer. So annual rye responds at lower temperatures than perennial rye, for example. So we know it's a more vigorous species. Whereas the other sites in winter were more temperature constrained, so probably didn't deserve a higher rate of nitrogen. At the same time, you can see the 2 irrigated sites, the 2 sites in Tasmania and Western Victoria. In spring, they had good moisture, good growth potential, and deserved a higher rate of nitrogen. Whereas in summer, for example, you'd be looking at the irrigated sites. So Elliott Research Station in Tasmania, Mount Gambier Centre Pivot irrigated, there was a fairly good response in summer because of no moisture limitation. And then the one thing I pointed out here is because under dryland conditions, Terang, Western Victoria, can be highly variable in summer. So you could get a good response to nitrogen, or you could get no response to nitrogen. That's that error bar that I'm showing you. That's the distribution of the actual raw data that made up that blue bar. So you get some idea of how variable it can be. So you really need to look at the soil moisture as to what response you can get to nitrogen. So what I'm showing you here is a whole series of response curves. I mentioned the diminishing returns shape of these response curves. So each one of them, as you increase the rate of nitrogen you can apply, there comes a point where you're no longer getting more response to increasing rates of nitrogen. And the point I was making in the earlier graph is how that optimum point changes depending on the site and the season. So what we've got here is Mount Gambier is the first column, Terang, Western Victoria is the second column. It's a dryland site. Mount Gambier is irrigated. And then Tauri on the right, that in this particular case, it was just winter irrigated in our analysis, just for example. What you can see is a winter across the top, spring, summer, autumn. So an average response shape. And the vertical bars you can see are the spread over that 20-year period that we ran the model for. So you can see what you're looking for is where the spread is tight. So Tauri, for example, in winter, annual ryegrass, I mentioned earlier, good growth potential, and it responds to a reasonably high rate of nitrogen in winter if you need that extra quality forage, because annual rye can respond at those lower temperatures under a subtropical environment, and if water is not limiting, you'll get a good response to nitrogen. Mount Gambier, a more muted response because it's far further south and it's perennial ryegrass, more sensitive to temperature. And so the limitation there to how high the rate could be is temperature rather than nitrogen. But look what happened in spring at Mount Gambier. You could respond to a far higher rate of nitrogen because water wasn't limiting and temperature wasn't as limiting. I guess I present this to show that the rate of nitrogen that achieves 90% of maxima isn't a constant. You need to think about the temperature, what species you've got there, and the soil moisture available. The other thing to look at here is the summer period in Tauri, for example. And you can see this high variance between the best response and worst response. And I guess that's just a reflection of a rain-fed system where soil moisture plays a big role, and you can get years where you have east coast lows and you get years where it's a lot drier. And so the ideal rate of nitrogen probably doesn't change as much, but the amount of return you can get from that summer Kaikyu can vary quite a lot. I guess those are the points I wanted to make on that. But the main one I want to come to is, this is some data from Peter Beal on soil moisture profiles. And the point to make here is it's not always nitrogen that is the first limiting factor. And if moisture is first limiting, you need to question the value of putting on the nitrogen. We'll come back to this in a moment. But obviously, leading out of the autumn into winter, the soil moisture profile looks better. And so you can get a better response to nitrogen at that time. The January-February period, well, Kaikyu's probably got fairly deep roots. If you wanted the response out of Kaikyu, you could get a response, I guess, but it might not be cost effective. And then the question around the declining soil moisture through late spring into October. Again, you'd be saying, if you're in October, you've got a high value ryegrass there. If you could get one more grazing out of it by a good prediction of rainfall coming up, you might hedge your bets on that, but you'd need to know that the rainfall was coming because you've got low soil moisture in that October period. And if you don't get follow-up rain into late October, the response could be quite muted and you might get a lot of Kaikyu. Just a question of Kaikyu and summer nitrogen. What I'm showing you here is some work that Andrew Smith did with us in comparing annual ryegrass only, which is the green, So that's only applying nitrogen fertilizer to the annual ryegrass. And there you can see from June, for example, so we're establishing it sometime in April, May, and we're getting a good response in June, July, and the peaks that you can see in August, September, that's nitrogen fertilizer going on to annual ryegrass. The annual ryegrass plus, which is the orange, is where we just added a few more applications of nitrogen into the early Kaikyu growth period, but not all the way through the Kaikyu growth period. And there you can see it had a bit of a tail effect. So when you came into the summer period, the green through the January, February, March period didn't give you much extra growth because there was no nitrogen applied there. It was only applied during the winter period. The orange gave you something because it was a carryover effect of that late spring application. And then the blue line is where we just continually applied nitrogen fertilizer to both. So I guess the message here is Kikuyu will respond to nitrogen. It will give you extra growth if you apply it. If you've got soil moisture there, you need to decide whether that is a cost-effective strategy or not, because the Kikuyu is probably at least 2 ME units lower than the ryegrass. And in this analysis that Andrew did, we found that it was about equal to put on fertilizer versus to supplement the cows instead. So that brings us to a discussion on the timing. And what I'm showing you here is what I would consider a typical Kaikyu growth rate pattern. So the blue line, where you get that late January, February, March peak, and then you get a drop into winter as you cross over to annual ryegrass. And annual ryegrass, obviously the orange. And there's no doubt that if you've gone to the expense of putting in annual rye, oversowing it, you've spent the money, it is a vigorous species of a very high quality. And so you really want to get as many grazings back out of the annual rye as you can possibly get. And so that's why the blue lines are there saying, this is the period where you can get that response to nitrogen and fairly cost effective if you look at those graphs on the right that I have just represented to you. So the top one being the winter growth curve, so fairly tight response to nitrogen on average over a 20-year period. Spring, still a pretty good response to nitrogen. But as you come into summer, it becomes more variable. So as you come into this period here, the question of soil moisture becomes a bigger issue. So if you're irrigating your annual rye, it's probably not a big deal. You'd really want to get the best out of your irrigation and keep going with the nitrogen. If it's dry land, you want to watch the soil moisture fairly carefully to know that you've got enough soil moisture to get a response to nitrogen. Then if you can get that late October, early November, if you know there's rainfall predictions coming, even though soil moisture is low and the rainfall might pick up the soil moisture, you could get a response there. And then I left those question marks around the summer Kaikyu. It depends on your strategy. You can get a response to nitrogen from Kaikyu, particularly because of the soil moisture through the late summer period. That depends on your strategy. But at that crossover period where you're now coming into the end of the Kaikyu and the establishment of the annual rye, again, what you really want to do here is look at the performance of the paddock. Is it performing well? Is there a lot of mineralization? Is there a lot of residual nitrogen? Does it need a good dose of nitrogen to get the annual rye going so that you can, as quickly as possible, restore the growth rate either of the Kaikyu or the annual rye getting into it? And just talking to Peter Beal before we started this webinar, we think the key there is put on the nitrogen, but make sure that you graze it fairly hard within a few weeks after to keep the Kaikyu under control and allow the annual rye to come through. So there, nitrogen's probably not the big issue. It's the grazing management after that guarantees the annual rye comes through. Now, we produced a number of case studies, fact sheets through Dairy Australia, and this is just an extract of a table in that case sheet, that case study, where we asked for local opinion on, in winter and spring on annual rye at Taree, what would be a typical flat rate, a regular recipe for putting on nitrogen? And it seemed to be somewhere around 40 kilos of N. So We compared 40 kilos of N to what the model told us for those 20 years, what would be the rate that would give us 90% of maximum potential yield. And for winter on annual ryegrass at Tyree, the model would say, well, actually you could get a response to a higher rate of nitrogen. You get a response to 50 kilos rather than 40. And that would probably get you an extra 200 kilos of dry matter per hectare of high quality, high ME forage, net impact about $21 a hectare. In spring, again, it's said that you could go into the slightly higher rate, but note that it was a bit more modest in the extra response. Yes, it was worth doing, but you were probably between 37 and 46 kilos of N. You were probably playing on the top of that diminishing returns curve, which is why it only gave you an extra 100 kilos of dry matter and around $10 impact. So I guess the message here is the nitrogen we think should be applied strategically, and you should look at what the base mineralization is, what the base fertility is, what species you've got, what the soil moisture is, and determine what the maximum rate you could get would be. And it might not be the same each time and each month of the year. Just to finish off, this was an interesting study that Andrew Smith and I and a few others were involved in, which looked at the idea of a flat rate of nitrogen, which is that first column, and then a strategic nitrogen, which says we're going to not just put on a fixed recipe of nitrogen, we're going to apply nitrogen according to the conditions to get 90% of maximum yield each time. So we're looking at the soil moisture, we're looking at the time of the year, the temperature. And then you can think of those next few bars as being increasing levels of precision knowledge. So for example, PS and PP is if we had soil sensors sitting there that could tell us exactly what the soil nitrate was, or we had plant sensors that could tell us exactly what the leaf nitrate was, and we were fertilizing to those levels of precision information. And then the last two is daily applications to meet the nitrogen requirement on a daily basis of either the soil target or the plant target. So just think of it as moving from a flat rate to best practice, and then increasing levels of precision knowledge. How much better could you get? And I guess the key here is there's quite a savings in fertilizer moving from a flat rate of nitrogen to more strategic nitrogen. But increasing levels of precision didn't save a whole lot more on that. So you can see that information. In terms of dry matter yield response, there was definitely a benefit of putting on nitrogen. The 0R is no nitrogen versus a flat rate, which gave us 8 tons in this particular case. Strategic gave us 7, and then there wasn't a lot of difference between them. So if you look at the first two bars on the left graph, when we moved from a flat rate to a strategic rate, we saved on nitrogen fertilizer, but the graph on the top right says we didn't save much. That didn't make much difference to the dry matter yield. So cost effective. But finally, in terms of losses, obviously putting on no nitrogen, so the 0 rate, gave us almost negligible losses to nitrogen. Putting on flat rate of nitrogen, because we put on a higher yield, that you can see in the top left graph, that second bar says we lost a lot of nitrogen, but we didn't change the dry matter yield on the top right. When you went to strategic nitrogen, where you thought about the rate each time and only put on what the plant soil system needed, not only did you save nitrogen, so if you look at the top left here, you've saved some nitrogen, but you've reduced the nitrogen losses quite substantially. What was also significant, though, is increasing levels of precision knowledge didn't seem to make a big difference to the nitrogen fertilizer, didn't make a massive difference to the yield, and didn't make a big difference to the losses. So I guess the key message here is just moving from a flat fixed recipe of nitrogen at each interval to adjusting the nitrogen to the conditions could save your nitrogen fertilizer, won't have a big impact on the yield response, and will reduce the nitrogen losses to the environment. So I guess that's what I had to present, Marguerite.
Thanks, Rich. And I think there's some really, really important messages there that are high level relevant to everyone, whether it's irrigated or non-irrigated, around that flat versus benefit to the strategic approach versus the little gains that come from the precision. So, you know, there's definitely that huge amount of benefit to be around that flat to strategic. Also importance around that relationship between soil moisture and also actually utilising the benefits gained through grazing management and the use of obviously good grazing management practices to suppress the Kaikyu in that transitional period.